somewhat of a video response to CellGen Studio's video on his RCA. Today I would like to show and demonstrate my RCA MS2000 MicroDisk development system. This is somewhat of a video response to CellGen Studio's video on his RCA MS2000 development system. The RCA MS2000 seems equally as rare, as this is the only one I've seen mentioned online, but despite this is surprisingly well documented. Software preserved for this computer consists of the RCA MicroDos operating system, RCA Basic 1, which is a very limited dialect of BASIC, and a PLM compiler. In addition to this, a member of the 1802 COSMAC community ported a copy of Basic 3 for a similar machine to the MS2000. I will be demonstrating some of these later. To start with, the RCA MS2000 is a computer based around the RCA 1802 COSMAC processor, configured with 2 kilobytes of ROM and 62 kilobytes of RAM. The construction of this particular machine uses RCA microboard cards slotted into a 20-slot backplane, along with 2 early Sony floppy disks, drives and a power supply. 8 slots are left empty for system cards, 4 here and 4 here, and other options which I will elaborate on later. I/O is predominantly done through these 2 disk drives and a serial terminal interface. It lacks any other form of I/O outside of a PROM burner, though I believe other options could be added in. However, I do not have any of those options myself. It's a quick tour to prove that there is no other I/O. There is empty side here, empty back here, and this side does have a side plate, but I do not have it fitted. However, you can see the 1805 COSMAC processor, which is a variant of the 1802. There is also a little slot here so that the serial cable can come out, so you can connect it to a terminal. Okay, let's take this puppy apart and see what's inside. So, each of the all of the microboard cards are in these 2 slots here. There's 4 slots behind each of these panels. They simply come out with some Phillips head screws. Inside here we have the CPU card, which simply comes out like this. CPU card. This has the serial interface and some other logic, but is surprisingly unpopulated, as this one was particularly optioned out for the MS2000. It's worth adding that these cards are sort of off-the-shelf components that RCA produced, and you could option out several different machines. So you could option your machine out with several different of these cards as and when and how you felt. They're quite easy to configure. There are jumpers on some of these cards, so you can change memory addresses and other options as well. While I'm here, I will mention that there were colour graphics options. I should have written this down, shouldn't I? Parallel, that's what I'm looking for. Parallel for terminals, printers, and a lot of other options, including tape drive interfaces and such like. So this is the floppy drive card. Contains a NEC 765 floppy drive interface and a bunch of glue logic to operate the floppy drives. I believe this could operate 5 1/4 inch drives as well as the Sony ones that it's configured with, but I don't have any way of testing that. So just looking at the software inside that it runs on, I suggest that could be the case. So those are the CPU and the floppy drive controllers. Behind this panel is the memory. So this machine comes with 2 cards, supporting up to 32 kilobytes of memory each. However, one is optioned for 32 kilobytes of memory and one is optioned for 28 kilobytes of memory, no, 30 kilobytes of memory, sorry, plus a 2 kilobyte ROM. The ROM is a monitor program that allows you to do some debugging, memory tests, so on and so forth of the machine as you power it up before you load the operating system. So this is the 32 kilobyte ROM card. Notice most of it is soldered and not socketed. The sockets are ones that I've replaced trying to get this card functional again. But it is quite simply a big array of RAM. Not much else in the way of glue logic. Put that fella back in. It's a bit finicky when you're not looking straight onto it, I'm not going to lie. So I do apologise about the shaky cam, even though I don't actually have shaky cam. Bear with, I just want to get this slotted back in properly. As you can imagine, having quite a rare machine, you don't want to balls it up. So I'm kind of doing this a little bit off script at the moment, as you may have noticed with my umming and ahhing. So this card here is practically identical to the last one, except it seems that most of it is socketed and there is a lot more jumpers on it. So we have a whole array of 30 kilobytes of RAM plus the UT71, if I hold it up this way, the UT71 monitor ROM. And that is essentially the 4 boards that this machine consists of. There is very little else in it. There is also actually, this machine came with a, come on, get in there. This machine came with a PROM burner. I have absolutely no information on it. It seems to be a third-party PROM burner. If I reach over, it's over here. It seems to be a third-party PROM burner, and I have absolutely no information at all on this particular card. No information at all. I don't even know if it works with the PROM 25 program that the MicroDos comes with. Anyhow, let's just double check that these cards are all slotted in properly. Yep. So, I think the next spot would be to take out, in fact, let's go and put these panels back on. No, that one uses the black screws. Try and keep the screws associated with their particular cards, although it doesn't really matter. I just like it from a visual standpoint if it all matches how it was. Let's pop this back on. I do apologise, there's going to be a lot of rambling because I'm not intending to do too many cuts on this video. It's going to be a bit rough and ready. However, hopefully I will put in some screenshots and stuff as I elaborate next on the actual construction of the thing. It's worth adding that the chassis that this came with is an off-the-shelf RCA industrial chassis, and the 20-slot backplane in it is also an off-the-shelf RCA part. In fact, despite the particular rarity of this machine, it seems to be built almost entirely out of off-the-shelf RCA parts. There seems to be very little that is unique with it. You could buy the floppy disk drives as an option for your own configuration. The power supply you could buy as an option for your own configuration. The chassis, the cards inside it, it's essentially all off the shelf. However, it just happens to be configured in this configuration out the factory. I believe that these machines were used for software development, much like CellGen Studio's MSE3001, although it seems to be a lot cruder in its construction and operation, as it doesn't have any doesn't have any debugging features as such. It's basically a simplistic 8-bit system, really, with nothing much more than a serial input, output, and a floppy drive. I've just realised that I need to unplug the floppy disk drive. So bear with. Is there anything else I can talk about? Power supply is quite unique. There is some logic in it that operates the program counter. So these switches, if you toggle them up, that will halt a program and halt the operation of the machine. Either one will do that, and if you press down on these machines, they will set the program counter to 8,000 in hexadecimal, or all zeros in hexadecimal respectively. So let's pop these floppy disk drives out. So unplug that again. So everything in this machine seems to slot in and out of this backplane. This is quite a hefty module. Let's push this machine back. So let's clear these screws out of the way. Right, this machine consists of two OA D30V, that's upside down though, OA D30V Sony floppy drives. These were the earliest floppy drives that Sony ever made in the 3.5-inch format, and are surprisingly compatible with modern floppy disks. I was quite successful in being able to write bootable disks out of a Dell machine with some special software. So getting this thing working was actually fairly trivial, despite its particular unusual disk format and just its oddness in general. So yeah, there's two floppy drives. There is a small controller board on the back, which I think does some power supply jiggery-pokery. I'm not entirely sure. There is a couple of beefy capacitors in there and some diodes. I'm no real electrical engineer, but I imagine that they do some funky stuff to do with voltages, because it's worth noting that the power supply outputs both 5 volts and I believe 15 volts. So I imagine that there is some conversion needed to be done to operate these floppy drives. These floppy drives seem to have worked perfectly fine. I just needed to ungrease them to free up the heads, not the heads, the drive loading mechanisms, and they pretty much worked flawlessly. As you can see, this module slides in using the same rails as the cards, and it takes its power off the backplane. So there's no messy wires or anything to worry about inside. It's surprisingly well built for something that is basically unknown. Anyway, so that's the floppy drive. We'll pop the screws back in. It's worth noting as well, while I'm here and talking about floppy drives, that this uses a 315 kilobyte format, single head, 70 tracks I think off of the top of my head it is, although the software does appear to be able to support 80 tracks and dual heads, though I don't have any compatible floppy drives to test it with. I imagine if you were to dig about online and get the schematics for the boards and such, you could probably build a clone that utilised dual head 80 track drives. The software seems to support it from what I've seen. I've not tested it, but I see no reason why you couldn't use 720k discs. However, whether you can find enough software to run to utilise that 720k of storage is a completely different matter. There is very little in the way of software available for this machine, though it is not non-existent. As I said before, there is a disk operating system available that a kind gentleman on the COSMAC group recovered and imaged the disk for. There is several compilers available, including a basic 3-ink interpreter, which somebody kindly ported, and there's something else. Yeah, that's basically all of the software that there is. However, there is also an emulator available for this machine if you wish to try it out yourself, called the MicroDisk, and it emulates several 1802 systems, including this one. In fact, I've done a lot of testing with the software and the operating system through the MicroDisk emulator. It has proved invaluable in trying to restore this machine, to be honest. As though it is well documented for such a rare machine, being able to play around with a emulated system is much more convenient than digging this thing out all of the time. Anywho, so that's basically a quick rundown of the construction of the thing. Alright, time for a demonstration of this thing in action. I'm sure if you've seen any photographs that I put on of this machine on Reddit, you will have seen this EPC before, but I use this for my terminal interface, just because it's easier than dragging out a full-blown VT420, which I have just off camera. However, I've not quite got that working with this before, so although it is something I'm planning to do. Anyway, enough waffling. Let's turn this thing on. I'll just pop the lid down so you can see the switch. Somebody has helpfully labelled it to the on position for on. So if we switch it on, I have a bunch of lights. There will be a seek noise from the drives. 5 volt comes on and the run light comes on. As I said earlier, if we toggle this up, that will stop the run. And now the machine is in a halted state. So, let's flip the lid back up. I'll just turn it off for the moment. And the machine's gone to sleep. This is a bit annoying. I didn't anticipate this. Right, yeah, cool. Right, we'll keep going, Let me just turn it off while I put the disc in. I'm a bit wary of putting discs in with this thing running because for some reason drive 0 is always spinning if there's a disc in it or not. I don't know if that's a fault with the drive or just the way it happens to work, but better safe than sorry. So we'll load the drive in. Oh, by the way, because this is an early Sony floppy drive, it expects discs that have locking shutters. So all of these shutters are taped open with the post hole here poked through so that it will load properly. Anyway, pop this in, switch on the machine. As you saw earlier, the run light, 5 volt light comes on. We have a UT71 prompt on the terminal. Now if we type T, just T, no need for a carriage return, we'll get memory OK. So this is a sort of primitive memory test. There is a more sophisticated memory test available in the software, in the the MicroDos software, but I won't run that because it takes 10 minutes. There's also some other things you can do here. You can examine memory locations, you can copy data to memory locations, you can execute from a random location in memory, so on and so forth. It's quite a powerful little monitor actually for 2000 bytes. But essentially what it is a bootloader for the MicroDos operating system. So if we type L, and again L, we'll get a MicroDos 1982 RCA Corporation prompt. So this is a basic well, a simplistic disk operating system. So we can do things like dir, but to identify a drive we use a :0 for disk drive 0 and :1 for disk drive 1. It'll seek, it'll read the directory, and it will print out what we have available. There is more, but it has some kind of reasonably sophisticated protections on the directories. So you can hide files, so on and so forth. So most of the operating system is actually set as hidden files. So if I load up, let's load up Basic 1. This is the Basic 1 disk from MicroDisk. I've copied a bit of software from the RP disk image as well. So we've got something to demonstrate. If we pop that into the second drive, we can then do a dir space :1, and this will read the directory on drive 1. So we have basic1.cmp, that's a basic 1 compiler. Basic1.lib, that is a library for the compiled applications. We have youth.ba1, which is kind of a colony management game. I've played a little bit of it, but not a lot. And we have tic-tac-toe.ba1, which is noughts and crosses tic-tac-toe. And basic1.int, which is the live basic interpreter. So if we do basic1, hang on, I'm going to have to do this on my keyboard because me full stop doesn't work. Basic1.int space :1, no, not space, no space, :1. So that is running basic1.int on drive 1. No space, because you only need to do that if you're doing command arguments. It's all a bit confusing. It's worth noting that MicroDos Basic, can't find it. Okay. Yeah, it's worth noting that RCA Basic is nothing like Microsoft Basic. Not RCA Basic. RCA MicroDOS is nothing like Microsoft MS-DOS. It's a completely different system. It might share a few commands, but there is nothing similar to the two. So if you do intend to play around with this in MRO2, do bear that in mind and look at the user guide. There's one on BitSavers that's been proved to be invaluable for me. So let's try this again. Basic1.int :1. There we go. For some reason it just didn't want to play. There we go, we got the Basic 1 interpreter. This is a very simplistic basic. There is very little in the way of utilities in it. It's basically if-else statements, print, loops, and that's it. String support is non-existent. You have to roll that yourself. Yeah, it's very limited. I've had a play. I am planning to write a program in it, but generally it's a very limited bit of software. But there is some software for it, which is where we come in here. So now, if I just think off of my head, RFLN, this will read a file, and we want to read tic-tac.ba1 on drive 1. So that's now read in the tic-tac file. And if we do din, oh yeah, there's no real sophisticated drive operating commands or anything in BASIC. It's basically just a string of commands to save stuff. There's a manual for Basic 1 available on BitSavers that goes into it a bit more in detail, but yeah, it's a bit complicated. So we'll just wait here for a minute for it to load the tic-tac.ba1 file. Clickety-clack, clickety-clack. We should expect a couple of, yep, there we go, a bunch of carriage returns. Now if we do DIN, in fact, it doesn't even like that, so let's try again. It's finicky. I mean, oh God, I've not seen that one before. Oh. Let's see if it's loaded anything. Okay, yeah, it's loaded something. I don't know if it's correct, though. We'll try. We'll run it and see what happens. You've got list command and things like that, but very limited in the way of commands. So it seems to be loaded. So if we do run, it'll probably throw up and... Come on. You crashed. Something's crashed. Let's just reset it. Oh, it's my keyboard. That's what's the problem. Okay, bear with. Right, okay, sorry about that. That was my machine, well, my keyboard playing up in the terminal emulator, so apologies for that. Let me just full screen that and we'll get back to where we were. So again, I've typed in DIN to load in the tictac.ba1 file. This will load it up into the basic as it chunters along. Chunk, 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 chunk. It's got to read off of the drive, and it's not the fastest of machines, this. So bear with. There we go. Now, if we type run, we've got tic-tac-toe. Do you need instructions? Yes. Yes. You play X by typing a number of a square. I play 0. To start over, type the number 0. Okay. Yes. Please be patient with me. I think very slowly. It does. I mean, to play a single round of this, as you can see it writing the grid there, takes a long time. It takes about 5 minutes. So we'll play 5 and we'll let it do its thinking, and it will play its shot. Usually plays 9, just to spoil it for you. But there is some level of AI going on here, so it is doing some calculations. It's not just sort of, well, it is reading from an algorithm, but you know, it does do some thinking. Being an 1802 processor, they weren't very fast in their heyday, so do bear with. As I say, it does take a while. Of course, because this is quite a simplistic dialect of BASIC, it has to do quite a bit of and ahhing with memory locations and stuff to be able to actually do the logic itself. So here we go, it's played 9. See the X there, and it will print out 0 there for 9. And so on and so forth, and you can play tic-tac-toe. But there's an example of a bit of software for BASIC 1. So let's boot back to UT71. I'll pop BASIC 1 disk out. We'll load in BASIC 3. So, as I said earlier, BASIC 3 wasn't actually an MS2000 piece of software. It was ported from another machine that was very similar. It was originally ROM based, however it has been ported to run off of RAM, and the memory references inside it have been pointed to spare spaces in the MS2000's memory map. Also, a bunch of commands have been added to it so that it supports the disk drives, because in the original machine that Basic 3 was ported from, it only had a tape drive interface. So if I do, let's do dir1. Again, we'll just have a look at what's on disk drive 1. So we have Basic 3, which is the Basic 3 interpreter, and we've got a hello3, .ba3. So let's load up Basic 3 1. Oh, by the way, CM is the extension for executable files in MicroDos. A command MicroDos, I guess it means. I'm not sure. But you don't have to put that in if you're running an executable, so you can get away with just Basic 3. :1 for disk 1. So there we go, let's load this up. We'll ask for CW, C for cold, boot, W for warm boot. So you can reset the machine and hit W and it will keep the program that's loaded in the memory. But we'll do C. So this is a bit more sophisticated in that it has a bunch of drive commands, such as pload, space, quotes, what is it, hello.ba3, :1, quotes. This will load the the hello.ba3 program. If we do a list, you can see it's a very simple program. This is the first bit of software I wrote actually for the MS2000 that I have saved. I did write a couple of other Hello World programs, but let's see if we can get it to say hello in reference to Usagi Electric and his wonderful Centurion machine he's been restoring. So let's do a run. And there you go, it's printed out 5 copies of Hello World.